Hello, welcome back to Algebra. We're factoring trinomials of the quadratic type, meaning we have an x squared term as the leading term. And we've done part 1, part 2, part 3, lots of problems increasing the complexity. Here we get to part 4, and you're quickly going to see why I have taught you to do these problems the way that I've taught you. Specifically, what I've been teaching you to do is write your parentheses, pick your terms, and then before you even start playing around with the plus and minus signs, I've been showing you how to go and figure out if the numbers you've chosen even have a possibility of working. The reason I do that is because when we get to these problems here where the numbers are larger, there's a lot of different possibilities that you can choose. And so we want to eliminate the ones that won't work at all and only focus on the ones that have a chance of working. Otherwise, you're going to be writing until the end of time for some of these trinomials. So let's go ahead and take a look and see what I'm talking about here. This one's not too hard, not too many combinations, but we're going to increase the complexity as we go. 2 times t squared plus 5 times t minus 3, I ask you. I would like you to factor that trinomial. And you say, okay, I'm going to do that. I'm going to say, well, if it is factorable, I'm going to open up a pair of binomial parentheses. And then this term has got to be made up by multiplying these first terms. So 2 can only be written as 1 times 2, so I can write this as 2t and t. So there's only one choice here because 2 is a prime number. If this were a larger number, then I would have more choices to multiply to give me this. But here, 2t times t gives me this. And again, this one's easier as well because 3 is also prime. The only thing that multiplies to get 3 is 1 times 3. But just because I want you to get in the habit of it, I want you to come over to the side once we have our numbers, before we do anything with the signs, and we look and say, what will the inner terms give us? It'll give us 1 times t, so I'll write a 1 down. What will the outer terms give us? We multiply. 2 times 3 is 6, so let's write plus or minus 6 down. Can 1 plus or minus 6 ever give us 5? Well, 1 plus 6 is 7, 1 minus 6 is negative 5, but we're looking for the absolute value. So the 5 matches with the 5. We think that these numbers might work the way that they're written, right? So we go ahead and try that. We want to pick the signs next. So the next thing we do is we pick the signs. We have a negative 3 here. These last two numbers need to multiply to give us negative 3. So right away, we know we cannot have plus plus because that would multiply to give us positive 3. We also know we cannot do minus minus because that would multiply also to give us positive 3. So we have to have differing signs. So let's just pick one, plus and minus, and see what happens. We know the first terms are going to work. We know the last terms are going to work. So now we go and multiply out. These terms will give us 1t. And these terms, negative 3 times 2, will be negative 6t. When you add these together, negative 6 plus 1 gives you negative 5. So it looks like it works, but actually gives you negative 5. So this set of signs actually does not work. So we'll try again. But we think these numbers work, so we will go and retain the numbers 2t, 1t, and 3, but we'll flip the signs, minus, plus. And then we'll do the same thing again. We'll go through a mental exercise and we'll say, well, the first terms work out, the last terms work out. The interior terms give us negative t. The exterior terms give us 3 times 2 is positive 6t. And when I add these, 6 plus a negative 1, that does give me a positive 5. So this is actually correct, and we'll circle that as our answer right here. Now, the way you'd really show it is you'd say, well, 2 times t is 2t squared. Outside terms, 3 times 2 is 6t. Inside terms is negative t, and last terms is negative 3. And you can see that everything matches, and the interiors give us the positive 5. So this is the final answer. And you might say, well, okay, that's exactly what we've been doing before. I thought you said these problems were going to get harder.